Hey everybody, hope you guys had a great weekend. Hope you're doing all right. For those of you who missed this morning's Zoom session, you missed out on your first Zoom extra credit opportunity. I'm going to start handing out extra credit opportunities during Zoom sessions to reward those people who are showing up. But in any case, you're still going to get your lesson today on using the quadratic formula. So to this point, we've solved quadratics. And we've had a couple different ways of doing it. The main ways were using magic number and factoring and then solving. And then we talked about completing the square last week. Today I'm going to briefly show you guys the quadratic formula, which is your third method for solving a quadratic equation. Now the nice part about the quadratic formula is you can always use it. Magic number is limited because it has to factor. But quadratic formula will work with problems that factor and problems that do not factor. So let's go ahead and take a look then at the quadratic formula and how we can then use it to solve quadratic equations. It is in your notes from last week, which have also been posted again this week. All right, so we're going to send me to the corner there. And let's head over here to our notepad. So far, when we talk about solving quadratic equations, our first option, like I mentioned, was magic number. So you would factor. Option number 2 was completing the square. And completing the square would work with problems that could factor using magic number, but it was really important when magic number didn't work. So option 3 is going to be the quadratic formula. You are going to want to memorize the quadratic formula. Now what I'd like you to do for each of your problems is to write the quadratic formula down first so that we can then get it drilled into memory. So the quadratic formula, and it's important for the quadratic formula that our equation is set equal to 0. So this is going to go back to like factoring where it needed to be 0. So I'm going to start off with a basic problem like this. X squared minus 3x minus 4 equals 0. And it equals 0, so we're good to go. If it doesn't, we obviously move whatever term is there to the other side. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now the thing we have to remember from earlier in this unit is that a, b, and c are the coefficients or the numbers that are in the quadratic equation. So a equals 1, b equals negative 3, and c equals negative 4. So to use the quadratic formula, we're simply going to take these numbers in front of the x squared, in front of the x, and this constant at the end, and we're just going to replace each of these variables in the quadratic formula with the numbers that we see here. So if I plug this in, x will equal negative b, so that's negative 3, plus or minus the square root of b squared. Well, b was negative 3, so it's negative 3 squared, minus 4 times a, which was 1, and c, which was negative 4, all over 2a, so 2 times 1. So I took these three numbers here and I plugged them in for the variables. And now we're just going to simplify and solve what we have in this fraction. So x equals, the two negatives become positive 3, plus or minus the square root of negative 3 squared, so that's 9, negative 4 times 1 times negative 4 is plus 16, all over 2. 9 plus 16 is 25. So this is x equals 3 plus or minus the square root of 25 all over 2. The square root of 25 is a perfect square, so that works out great for us. So this becomes 3 plus or minus 5 all over 2. And now because it's plus or minus, I'm going to set this up into 3 plus 5 over 2 and 3 minus 5 over 2. And I'm going to then simplify both of those fractions. Well, 3 plus 5 is 8 divided by 2 means that x equals 4. And in the second fraction, 3 minus 5 is negative 2 divided by 2, so negative 1. If I had taken this original problem and I had done magic number, factored, and solved, I'd get the same two answers. So quadratic formula allows me a method to plug in and get the solutions that's different than factoring. Well, this becomes crucial because what happens if magic number doesn't work? What happens if I'm given a problem where factoring wouldn't work? So we're going to give a second example here, and we're going to take x squared minus 8x minus 4 equals 0. Again, it is set equal to 0, so it's ready to go. If I tried magic number, I would find it doesn't work. I'm going to put a 1 in front of this x squared, so I have my a, my b, and my c. So quadratic formula, opposite of b, plus or minus b squared minus 4ac all over 2a. Again, we're going to write it down so that we can drill it to memory. Now remember, we're going to solve simply by taking the a, which is 1, the b, which is negative 8, and the c, which is negative 4, and we're going to plug them into the quadratic formula. So let's do that. Opposite of b, negative 8, plus or minus the square root of negative 8 squared minus 4 times 1 times negative 4. All over 2a, so 2 times 1. All right, let's start to simplify the top of this fraction. The two negatives make that positive 8 times the square root of negative 8 squared is 64. Negative 4 times 1 times negative 4 is plus 16. All over 2. Okay, so let's continue to simplify. 8 plus or minus the square root of 64 plus 16 is going to make 80 all over 2. 80 is not a perfect square, so I now need to simplify the radical. So I need to find whatever perfect square I'm going to have inside of 80, because if we look, and I'm going to go ahead and show you here, the square root of 80 is not a perfect square. So this is not going to work out as nicely as it did on the first example. So this answer is going to have a radical in it. So what I want to do is I want to think about what perfect squares are in 80. Well, let's take 80 and divide it by 16. And I picked 16 because 16 is a perfect square. So the square root of 80 is the square root of 16 times the square root of 5. Well, let's remember from simplifying radicals that as soon as I have a perfect square, I can take the square root of that and put it out in front. So the square root of 16 is 4. So this simplifies here to 8 plus or minus the 4, because that's the square root of 16, and radical 5 stays on the inside because it is not free, all over 2. Now this is as far as I can simplify this radical. So this answer is essentially done. There is one final thing that we need to look at for this particular problem. Now, this is not always going to happen, but it does happen for this particular problem. Everything that is outside of the radical, the 8, the 4, and the 2, and this is only the case if all 3 of these pieces can do it, but all 3 of those can reduce, because 8 and 4 and 2 are all divisible by 2. So if all 3 of these pieces that are out of the radical, and again, it has to be all 3, can reduce, we will. So my final answer is going to be to reduce all of them by 2. So this becomes 4 plus or minus 2 radical 5 as my final answer, because the 2 in the denominator cancels away. So let's recap briefly here what we did. We took the A, the B, and the C, and we plugged those numbers into the quadratic formula. Once we plug that in, we then solve each of these, simplify each of these terms until we get down to the radical. And then we had to find the perfect square inside the radical and put it in front. And then we reduced and put that final answer. And there are 2 answers here because of the plus or the minus, and those answers have a radical in them. So this was a lesson on using the quadratic formula to solve a quadratic equation. Your homework will follow suit. It's going to be quadratic equations being solved with the quadratic formula, worksheet 1. You guys have a great Monday, and I will see you later this week.